Dear world, welcome back in today's video to the binary tree operations. So previously we have observed all the binary trees, the concept, and in today's video mainly we'll be understanding the coding part, that how we can represent the tree. So let's start. So first we'll be understanding the binary tree node definition. So as you can see, this is a binary tree. So whenever we create a binary tree, so this is pictorial representation, but inside computer, this is the actual representation. That is the actual representation inside computer, and this representation is called linked list representation also, that I have previously made you understand. So that is the main architecture inside computer, and we have to write code for this one. That computer from this one is pointing to this one, this one, this one, this one, so they are pointing each other like this. So how we can represent it? To represent or to create any type of data structure, if we try to create this structure, so for that we have to write a class. So for creating any type of data structure, first we will be creating a class. So let's name this binary tree node class. So we'll be calling it class binary tree node. Class binary tree node, because we want to create a class, and for creating a class we always have to remember, first we have to create a class, then we have to declare the variables. So notice here are three variables. First, this middle one, that is integer data part, because here we always conserve the data, so we call it integer data. So first we'll be writing integer data. After that, this is and this is, these are the portions where we store the address of all those. Suppose the address is 100 and this address is 200, then we store the address here, then we store the address here. So this address is always stored, and the address is of type binary tree node. So we will be creating pointers, and that is called pointers with respect to that one, because they point to the node which are of binary tree node. So writing binary tree node left and right, because we'll be creating two pointers. So left, we'll be calling this one the left pointer, and that one the right pointer. So binary tree node left comma right. And now we have declared the variables. So we have declared the variables. After we have declared the variables, we must have to create a constructor. This is must. So now we'll be creating constructor binary tree node binary tree node. So this constructor will create a reusable binary tree node like this. Reusable. So whatever the value will be passing towards this constructor, this value will automatically get initialized with it. So binary tree node, let's call integer data. We'll be passing integer data. This will capture a new data. This section will always capture a new data that will be passing from the function. So now we'll be writing this dot data. This dot data, that is equals to data. And now the left and right. So left equals to right equals to null. Initially we'll initialize them with null values. So after this is done, what happens whenever we create a node like this, it will automatically store a null value inside this null. It will have a null value inside this, and this middle portion, that will contain the data value. This middle portion will contain the data value. So whatever the integer data, if you provide 4, then 4 will be here. So this is how a binary tree node is created. So we understood the binary tree node definition. So that is all about binary tree node definition. In next section, we'll be observing that how we can create insert operation. So we'll be creating this node. So now let's starting the binary tree insert operation. And for that we will just utilize the same one. So let's understand first, this is 1 2 3 4 5, 1 2 3. We're just considering this one. Okay, so this is our tree. So now we want to create a tree. Now we want to create a tree, and for creating a tree we also need to declare a new class in our Java file. So let's name the class binary tree. So we'll be simply calling the class as binary tree. Whenever there will be no tree, so we have to initialize everything from the beginning. So just try to understand from the first one, that node 1. This is what we call the first node 1, we call it as a root. So you can notice two things here, that we call it root only when it is pointed. That means if something is pointing, this pointer is called the root. This node is not called the root. This pointer is called the root. And there is a value. This is called the data or the value part, whatever we can call it. This is either the data value, we can call whatever we want. Here we have called data, so here also we'll be calling data. Okay, so here also we'll be calling the data. So this is root and data. So to create a class, to create a function, how we can create, we need two important things from there that we can conclude. That first we require a root, and then we require a data part. That means we have to create a function that will contain two things most importantly. One, root, what will point it, because if you don't point anything, it will not become a node. If we just remove this one like this, there is no pointer, so we'll only encounter this section, that this tree is consist of only those 1 and 3. Thus tree is the draft that is having no value. So we must always need a pointer, we must require a pointer. Let me just try. We always must require a pointer, or this is called root type of the reference. Okay, so we got it, we require it. So for creating or inserting binary tree node, first we have to create a class, and we'll be calling the class as binary tree. So we'll be writing like this, class binary tree, class binary tree. So first we created a binary tree. Now observe what we have. We have first the root variable. So we have to declare this root variable. So we'll be declaring the root variable like this. Okay, I'm using this color. So we'll be declaring binary tree node, because the root, this root is the pointer of this node. We'll be pointing this node. So we have to create the reference of that node type. So just we'll be writing binary tree node root, binary tree node root. So if we just observe or notice it, that what will be the architecture of this binary tree node. So whenever we have created this binary tree node, this node, so it is just like this. This root, this is in terms of programming like this. Root equals to null. So it is not having any value. It's ready to be used. It's having no value. It's just null. Now the value of root is null. So if you call the value of root, that will be null. Okay, now we have created the binary tree node. Now we have to declare the function, we have to create the function. So for that, let's create the function, and after creating the function, we have to return the main root also, which will be of tree node type. So the return type will be tree node. So let's create the function public tree node public, and this is the return type tree node, and the function, let's say insert, because we will be inserting data here. Insert. Okay, and two things we have to pass from here. Just let me make a little bit smaller. Okay, and in insert function we have to pass the root, as we know that we have to pass the root. So root is of type tree node root, and then we have to pass the integer value with what we have to initialize. Now after we have created the function, we have to declare the base case. We'll be declaring the base case. So the base case we always check is either 0 or 1. So we'll be checking if root equals to null, we are checking this root equals to null. That means if there is only one element, or there is totally no element. If the case is there is that totally no element, so we'll be just assigning we'll be just creating a new node, and we'll be assigning the new node to the root. So that will be like this, root equals to new tree node. So now we have created a new tree node, and we have to create with respect to this value. We can take either value or data. So let's call it data for better understanding purpose. Integer data. So root tree node data. So now data, it now got created. Now we have just created, we have inserted a root. Now we no need to do, we'll be just returning the root. So we'll write return root, return root. So here in this section, we have handled the base case. We have handled the base case. As you can see, we have started from the class binary tree node and we have handled here the base case. Now the second case is, that means now if we have passed from the main function, if you have passed let's say tree dot insert, let's say from the console, if you have applied this tree dot insert root, I mean tree dot root comma 1. So it would have created a node like this and root would be pointing like this. So it would be the pictorial representation, it would be like this in actual programming architecture. So that side, let's understand here. So after calling like this, that would be the architecture. So we have inserted one and this that contains null and that also contains null. So that is the first time when we have called the function. Now second time we will again call the same function, that tree.insert, because we have to insert the element. So let's see that we are again calling the tree.insert. Again we are calling the tree.insert, tree.insert, and now we want to insert the 2 in the same tree. Want to insert the 2 in the same tree. So we'll be writing tree dot root. Okay, I just made the different orientation. Observe, our orientation should always be same like this declaration. Here root is in the former, so we have to write the root in the former. So let me erase this one, just root comma 2. So we'll be passing 2. So what now will happen in the program, that this condition has been done. Now we'll be checking the value, because while insertion we have to follow some protocols and we'll be following the protocol of binary search tree. What the protocol of binary search tree tells, the protocol of binary search tree, it tells that if elements are lesser, then we will insert them in the left side. So data that will be lesser than the root dot data, that will be lesser than the root dot data, will be inserting them in the left side. And if the value of data that is greater than binary search string, that means if the data value is greater than binary search string, then we'll be inserting them toward the right position. That means the right data values will be always greater than the root dot data. So we'll be checking that condition, and this left will always be lesser than, will left will always be lesser than the root dot data. So now we'll be applying this condition, we'll be checking those conditions. So for that we'll be writing if the data value that we have passed, if data less than root dot data, so we'll be inserting a new node where in this part. That means we'll be inserting a new node here. We want to create a new node here, and for that we want to assign the new node in here. That means if that is the root, then we want to insert in this room and we call it root dot left. So we'll be just writing that root dot left equals to root dot left equals to insert. Now again we are calling the insert function, and now it will be recursive. So now we'll be passing the root dot left, this one, because we want to insert here this section. So we'll be passing root dot left because we want to insert in the left side, and we'll be passing the same data value. So again the function is called and it will move, and the value will get assigned. So this is when the data value will be lesser than the root dot data. Now we'll be handling the case when the data value will be greater than the data. if if data if data value is greater than root dot data, if data value is greater than root dot data, then we'll be inserting in the right side. So that will be root dot right insert. Again we're calling recursion, and it will be root dot right. Now we'll be passing this one as the root, because we want to store in that side. It is greater and we want to store in that side. So for that we are passing this root. This is always the root. The first one is always the root. And we want to insert with respect to that one. So that it is created here. So we'll be passing root.write comma data. So we want to pass 3. So it will be 3. So 3 will be stored here and 2 will be stored here. So this is how it happens. That is how the three cases are maintained, and at the end we'll be returning the root. Once we return the root, the entire tree will be returned. So at the end, whenever we'll be returning this root, that root is pointing the entire tree. This entire tree will be returned to the program. So at the end we have to return the root. So return root, return root, and after writing all the lines, our program will get finished. We can also check the entire program, but okay, let's write the program and we will be seeing how if it works or not. So for that, first we'll be creating, let's, okay. So now we can see the VS Code, and now we'll be creating a folder. So folder name command dot dot. Now we are inside the tree data structure and we will be creating a file mkdir make directory tree insert tree insert. So this is the file tree insert yt. Okay, and now we'll be moving into that folder tree insert yt, and now let's create a file code. What we name here, okay. Now we'll be applying the same code section as I told. So first we'll be creating a class binary tree node. So let's create a class binary tree node. Okay, so code binary tree dot java, and it created a code binary tree. Now we'll be first creating the binary tree node. So for that we'll be writing class binary tree node, and now we'll be declaring all the variables integer data binary tree node left comma right, and now we'll be creating the constructor so that we get a usable object integer data, and it will be this dot data, that is equals to data, and left equals to right, because for initialization we always want the left and right pointer null. So we created the binary tree node as you can see, and as I made you understand in the code. Next we'll be creating the class binary tree, binary tree public class binary tree. Okay, so we created a public class binary tree, and for this entire class I need to create a tree root, so that something points binary tree root. So this root is the root of entire binary tree class that I am creating. So binary tree. Now we'll be creating the file public insert. So the return type will be same as the data structure binary tree node. So public binary tree node, binary tree node. Okay, and now here we'll be passing the root. So the root, the data type of root will be same, the binary tree node, binary, it will be binary tree node. Okay, so this will be binary tree node. We'll be passing binary tree node, let's call it node, and we'll be passing the data value integer data, so the value that we'll be passing inside this function. And now first we'll be checking the base case or the terminating case or the stopping case. Okay, and now so we'll be writing if root equals to null. We'll be checking if the root equals to null. Root equals to null, that means there's no element. So we'll be creating our element. We'll be creating the element root, that is equals to new binary tree node, and with respect to the data value that has been passed to us, so it will automatically create a node. And now we'll be simply returning the root, to return the root. So we handled the base case. Now we'll be handling other cases for next one words. Look, we have inserted one element, so we cannot insert anymore like this, because there can be only one root in the entire tree. We can either insert in left side or in the right side. So if the value is lesser, we insert in the left side as per the rule of binary search tree, and if greater, we insert in the right side. So now inserting in the left side, as per BST, binary search string. So we'll be checking if root.data. First we'll be checking now if, let's call it, we have let's call it root, because every time we are using root, so whatever we call it root here, we have to compare with that. If we call it node here, we had to write node everywhere in this section, so we are calling it root. So we'll be checking that the data we are passing and the root data, if they're same, that means if data, the data we have passed through here, if this data is less than root.data, if so it was missing and I got confused that why is the function name. So okay, this is the function and we are inside the function. So now we'll be checking if the data value is less than root data. So we'll be just creating a new node in that section, I mean root.data, then we'll be applying the same recursion insert, and now we'll be passing the root.left because we want to insert in that section, and we'll be simply just passing the data value. Now again we'll be checking the second case, if the value is greater, so if data greater than root.data, so now we'll be inserting the right side, root.right equals to insert, and just we will be passing root.right because we want to insert in that section data. So we just created, now all everything has been inserted, we have to return the root, so we'll be returning just the root, return root. Okay, we just return the root, and this is binary tree node insert method. So you can call the enter function from the using the public static void main string args show leaves, and we have to create the, this is binary tree, so we have to create an object of type binary tree equals to new binary tree. Okay, we have created object, and now simply we'll be calling the function tree.insert, and now we'll be passing root from here, tree.root, because we are accessing the root of the same class file, root comma 1, so we inserted 1, tree.insert tree.root comma 2, again tree.insert tree.root comma 3. Okay, so now we have inserted a file, and now we'll be compiling this folder. So let's java compile minus d dot binary tree dot java. Okay, so the file got compiled. Now we'll be running java binary tree. Main method not found in class binary tree. Please define the main method as public static void main string args. So what wrong? Public static void main string args on Java say for the last time, and that's I got here. So okay, this program is running. Now what we want, we just want to see if the element got inserted or not. For that, if this was the method of insertion, we have to traverse also, and for that just writing a traversal method. Let's say we're writing the method of I mean prefix or infix. Okay, let's apply, if we just apply infix, so first there would be 1 as inserted, and then 2 and 3. So if you want to view, I mean in this way, that root first and then left, then we have to use prefix. Okay, let's apply in prefix, prefix traversal. Okay, so for that we'll be just writing public void